Here we are trying to explain some homework questions coming from chapter 9 when we try to compare two means. Before we explain the homework, just want to mention that I feel so brave to record my voice here. So pay attention to how do we solve these homework questions instead of paying attention to this unique Asian accent. Question number 1. If the test value for the difference between the means of two large samples is 2.57, when the critical value is 1.96, we are given this graph here, so you can see that the data is 2.57. That's coming from the data evidence. The 1.96 is the critical value is given. As we mentioned that before, we are using to indicate that, right? And the center here is H0. So we know that from the data is further away from the center, relatively speaking, compared with the critical value. So we know we are going to reject the center H0. So we are going to reject the long hypothesis. The answer is C. Question number 2. Consider the long hypothesis, the difference equal to 0. Now, the confidence interval for the difference does not contain 0. What's happening is, say we have this x-axis here, right? So we know, say, 95% of the time, that's the confidence interval. So what's happening is 0 is not in this range. So 0 is either to the left or to the right. So in that case, 0 is not considered, is not contained in this 95% confidence interval. So in other words, we should reject 0. So the null hypothesis equal to 0 should be rejected. That's true. Question number 3. When comparing the means of the samples from two normally distributed proportions, if the samples are independent and the population variance are given, then the z-test should be used. That's right. So catch the keywords population variance. We should use z-test. If it's given sample variance or sample standard deviation, we should use t-test. Number 4. A bond analyst is analyzing the interest rate for two states. Forgive me, I don't know how to pronounce this word here. That's okay, we can still solve this problem. Alpha is 5%. Do we have enough evidence to say there's a significant difference for those two states? Everybody, we are given the sample size, the average for those two states, and then population variance. Because of that population variance, we know we should use z-test. So the z-test formula is given here. Now, a tricky part. There will be quite a few people making mistake here is we are given the variance. So that sigma 1 square is 0.02. We don't have to square that again in the formula. Pay attention to that. If you square, in other words, if you put here 0.02 square and 0.04 square, you cannot get the answer. So I got a few students asking, somehow I cannot get the answer. So that's the reason. At the end, you should be able to get some number very close to negative 10.95. I mean, may not be exactly match, but it's some number pretty close. Question number 5. A sociologist wants to determine if the lifetime of people in Africa is less than the life expectancy of people in Asia. So that less than remind us if it's a hypothesis testing should be one side. And we are given sigma. That remind us we should use z-test, right? Sample size, sample average, all those are given. So sometimes some people will feel so excited to jump into the formulas, like using this z formula to do the calculation. Sometimes we have to check what's happening on the question. The question is asking us calculate the critical value. Remember, the critical value is coming from the table. Which table we should use depending on which formula we should use. Which formula we should use depending on which assumption is given here? We are given the population standard deviation. Tells us we should use Z formula. Then it is a Z table. If it's a Z table, alpha is 5%, right? So that reminds us, should we divide by this 5% or not? Here, because this one-side test remind us this all 5% should be on the left-hand side. Why is that? Because less than. That's on the left-hand side. So here is 5%. We can easily find out from the Z table the corresponding value. The Z value should be negative 1.65. Answer is B. Easy. Question number 6. A sociologist expected very similar question here. They are asking us calculate 95% confidence interval, so we have to use z-test, right? Because sigma is given. So one thing I want to remind you here is when we plug sigma 1 square here should be 8.1 square, right? They don't have a square here, so you have to 8.1 square here and then 9.3 square here. Otherwise, you cannot get the answer. Number 7. A test was made, mu1 equal to mu2, compared with mu1 less than mu2. Sample average x1 bar, x2 bar are given. Sample standard deviation also given. Sample size given. Now, we can easily say, based on those information, we should use t-test, right? You can jump onto the t formula calculation. But we have to check what's the question asking us here, right? They are asking the degree of freedom. We don't have to use the formula to do the calculation. We just need to find out the degree of freedom. Remember, if we have two sample size, n1 minus 1, n2 minus 1, we are going to use the minimum one. That's easy. Number 8, we want to compare two groups of people, right? Freshmen and seniors. So we are given the sample size, sample average, population, standard deviation. Everybody? So that's sigma 1 is equal to 52. So when we are using the formula, right, we should use z-test because population, standard deviation. So in the formula, we should have 52 square. Do not forget that square. Number 9. A test compare mu1 equal to mu2 compare with mu1 less than mu2. All the information is given. In this case, the question they're asking us calculate the test value. So we plug all the information into this T formula. Everybody, why is T formula? Again, because given sample standard deviation, we should use T formula. Easy. Number 10. A garden seed wholesaler wished to test the claim that tomato seeds something faster when each individual seed is something within something. Well, I don't quite get what those two words, right? So that's okay. I can still solve this problem. So we have two groups of data here, right? One is the control group. How many seeds here we have? We have 6 seeds. And then another group, palletized. We also have 6 seeds. Be careful, everybody. Here, even though they put here like almost like a pair together, right? But it's not a paired matched case. In other words, it's not the case we have mentioned in class, like before and after. Before and after is not like those. So here we should treat them as independent sample, right? So what we are going to do here is we are going to calculate the average for each sample here, right? The average, the sample standard deviation using that beautiful formula. Similarly for this sample here, the sample average, the sample standard deviation. Based on that calculation, to plug into the formula, which formula we should use, right? We are calculating the sample variance. So we should use t-test to do the hypothesis testing. Everybody, this problem here will take quite a few minutes to solve that. So if you see that on the final, you probably want to do that as the last one. Question number 11. Test the difference between two group average. So we are given the sample average, the sample variance, sample size. So in that case, we should use t-test, right? Because sample variance. And then plug all those numbers into the t formula. Be careful here. When we plug into the formula, should be 550 divided by 10. We should not have 550 square divided by 10. Be careful for that. Number 12. 12 dieters lost the average of 5.2 pounds. That's one group. The control group here also have 12 people. They lost the average of 4.5 pounds. We are given the standard deviation of that group, so we consider sample, right? So we have S1, S2. Which formula we should use? We should use T formula. So you can see that here, the T formula we are using try to calculate the confidence interval, right? So after we plug all those numbers, be careful, we should have 2.8 square here because that's the standard deviation, right? If it's given the variance, then we don't need to have the square. T alpha divided by 2. How do we get those number? Those number is coming from the critical value, remember? Right? So we are using the T table to find out the T alpha divided by 2. Alpha is equal to 1 minus the confidence, which is 5%. So 5% divided by 2 is 2.5%. So you are using the T table. Remember, the first two rows is one tail or two tail, right? Based on the question here, we are trying to, because it's a confidence interval, right? So always two tail. Or you can say, using the T table, check the bottom. That's for 12. Number 13, someone wants to determine if the average price of the wine, imported wine, is less than the average price of domestic wine. So it's one side, is right to the left. The information is given, the sample standard deviation. So if we are going to use the formula, we should use T formula. Do we have to calculate that? No, because they are asking what's the critical value. So how do we find out the critical value? Is coming from which table? T table. So from the T table, when you check the first two rows, right, is one tail or two tail? Check here, is one tail. Alpha is 5%. Get that 5%. Tell you which column you are looking for. And then find out which row you are trying to select. So determined by the degree of freedom N1 minus 1, N2 minus 1. Choose the minimum one. Then you will get the critical value. Number 14. A marketing firm asking a random set of married women and married men how much they are willing to spend for jewelry as a present for their spouse. Alpha is equal to 5%, right? They are trying to see the difference. So we are given the sample size, sample average, and the sample standard deviation. We should use t-test. We should have 34 square divided by 9, right? Because it's standard deviation. You plug all those numbers into the formula, you should get the answer pretty straightforward. Number 15. A reporter bought hamburgers at a randomly selected store of two different restaurant chains. So we have a chain A and a chain B. Sample size given, sample standard deviation also given, right? So we want to test the hamburgers from those two chains have a different number of calories, right? So is that a significant difference or not? We should use t-test because we are given sample standard deviation. So we should have in the formula 23 square divided by 7, right? Because here is S1, is not S1 square. Everybody be careful. And then the last page is the answer.